All right, we are at the top of the hour, so we're going to go ahead and get started. Hello everyone, and thank you for joining the Tape Storage Council for what has come to be referred to as the annual State of the Union address for the tape storage industry. The discussion today is focused on tape's role in the data center and cloud for 2013 and beyond. I'm Bob Cohn, and I'll be introducing our guest speakers and moderator for today's discussion panel. As most of you know, the Tape Storage Council releases a memorandum on the trends, usages, and innovations occurring within the tape industry each year. This year's memo is especially interesting because it focuses on tape's role in what is referred to as the modern data center, where in addition to more traditional roles in backup, disaster recovery, and compliance, tape is seeing significant growth in active file archive, low-cost NAS storage, and deep archive offered by cloud providers. And clearly that growth is reflected by the numbers. Tape capacity shipments grew 13% in 2012 and are projected to grow 26% in 2013. The memo outlines several of these new use cases for tape by some of the most influential data centers in the industry. NCSA, where under their Blue Waters supercomputer they've deployed a 380 petabyte tape storage solution for nearline production data with read-write rates up to 2.2 petabytes per hour. The National Institute of Health, who uses a tape-based archive to access, analyze, and manage huge volumes of molecular level data. Major League Baseball, recording between 25 and 30 terabytes of video data on tape each day and operating a tape library over 13,000 LTO tapes strong. The list includes organizations using tape in the cloud like Permavolt, T3 Media, and the University of California, post-production companies like Optimus, where tape is a critical component of their tiered storage environment, and finally SciArc, charged with protecting the history and cultural heritage sites through digital scanning and 3D modeling, with their mission to add over 500 sites and nearly 2 petabytes of data over the next 5 years. The open format LTFS assures accessibility now as well as far into the future. And we'll actually be hearing from both NCSA and SciArc on the call today before we go over to our panel discussion. And hopefully both of those users who will be presenting can be a part of that panel discussion as well. For those of you who have already read the memo, the cumulative numbers are impressive. 20,000 petabytes of tape capacity shipped in 2012, and over 25,200 petabytes are projected for 2013. Mid-range and enterprise libraries in the range of 100-plus slots grew by 8% year over year in 2012, and the enterprise tape automation market posted nearly 30% growth. But I think the smaller scale numbers tell an even more interesting story here. If you look at LTO6 cartridge capacity, it's doubled the capacity of the previous LTO5 generation and gives a 40% performance boost. Tape drives and media have the longest shelf life of any storage technology today, with tape drives averaging 7 to 10 years and tape media shelf life at 30 years, which is impressive when you consider the average lifespan of disk is only 3 to 5 years. And tape's reliability is anywhere from 2 to 4 orders of magnitude greater than that of the SATA drives. Now, when you combine that capacity, performance, lifespan, and reliability with tape's TCO, the story really gets interesting. One of the most interesting topics of discussion today, and I'm sure our panel will cover this, comes from advances in tape management software, including the Linear Tape File System, or LTFS, which have significantly expanded tape's use case. You'll see tape being deployed in Tape as NAS active archive solutions, where one study shows the 10-year TCO is 84% less than the equivalent amount for a storage system built on 4 terabyte disk drives. And being able to access cold, or what is sometimes just simply referred to as infrequently accessed data, within 60 to 70 seconds from the time a file is requested gives tape a great play in the NAS space. It's an exciting time for tape. We'll be collecting questions throughout the webinar, so please use the chat box to submit any questions you may have, and time permitting, we will do our best to get to those questions at the end of the call. As I mentioned, before we jump to the panel discussion, we're going to start from hearing a few of the people who use tape and use it in a very big way. We'll have Michelle Butler presenting for NCSA, where, as I mentioned, their supercomputer is using a tremendous amount of tape storage and capacity. It's interesting, one of the things that has really driven our ability to do the processing we do today and work with data the way we work with it comes from the supercomputing world, so that will be a very interesting conversation. And then we will have Scott Lee representing from SciArc, who also use tape in a very interesting way to preserve World Heritage Sites and the history behind them for hopefully all time. So with that being said, we're going to start with Michelle. And Michelle, are you with us?
I'm here.
Okay, great. Go ahead and start, and then I'll advance slides as you go through. Welcome.
Well, thank you. Thank you very much for inviting me. I am a storage engineer here at NCSA. Actually, I'm in charge of the storage group. We take care of all the storage systems, not only on the Blue Water system, but all the other supercomputers that we currently run here. We're housed at the University of Illinois in Champaign, Illinois. Wanted to talk to you about the Blue Water system. It is the largest scientific supercomputer today, devoted directly to the National Science Foundation applications for time. So it's been in production since early in March. The users actually get onto the machine by writing proposals to the NSF. They're peer-reviewed, and then they ask for time on the supercomputer. It was a $200 million proposal that NCSA and the University of Illinois won from NSF. The machine is primarily a contract with Cray. It produces very large, simulations depending on what the user actually asks for. This is not a machine that's dedicated just to like the Department of Defense jobs or anything like that. It is dedicated to anything that the scientific user would want. So this can be used for calculations for all the way from cosmos all the way down to AIDS to how a virus could be spread across the United States. There's all types of science that this machine is doing. It is geared toward very, very large jobs because the machine is a terabyte or a teraflop, basically, or a petaflop in calculations. So in this first slide, it talks about if you could multiply two numbers, it would take you 32 million years as a person. If you used every single person in the entire world, and they did a calculation one every second, it would still take us 1.5 days to calculate what this machine can do in 1 second here. So it's a very powerful machine. It is made up of hundreds of thousands of CPUs, and we have some GPUs dedicated to this machine depending on the computing type that the user wants to do. You can go to the next slide if you want. The machine has more than 1.5 petabytes of memory. That, as you can see, you can store 300 million images from your digital camera. Has 25 petabytes of storage. In fact, one of the file systems that we manage, it runs Lustre File Systems. We manage a single file system in 21 petabytes of size. Now that's actually usable. That's what the users actually see. There's about 36 petabytes of raw because it's all striped and rated and et cetera. We have, as you guys already heard, we have a 380 petabyte archive. It is scalable up to 500 petabytes easily. And the thing that we've been trying to measure was basically it's enough to store 10% of all the words that have been spoken in the existence of our humankind. I also run the older archive. This is a brand new archive that's just been put on the floor in the last 6 months to a year. But the old archive took us 19 years in 2003. It took us 19 years up to that point to store its first petabyte, and that was such a big goal that we had. Then it took us 1 year to store the second petabyte because our storage always doubles every year. The Blue Waters machine took its sweet old time putting its petabyte in there. It only took it 6 weeks for our users to put a petabyte in our archive system. And now we're growing by a petabyte a week in our environment. It is very large. It is very intense. We studied in the beginning to do our archive system only on disk so that we wouldn't have to deal with tape. As we all know, there are tape problems. There are media and all kinds of things. But we couldn't afford disk for 500 petabytes. It was too expensive. We also currently in our old system, we mirrored all of our tape so that if we dropped a tape or the library would smash one, we had a duplicate copy of it in another building. Our media cost for 500 petabytes was $16 million. The NSF we didn't think the NSF would actually give us another $16 million just in media costs. So we actually also developed a software solution here called RAIT, R-A-I-T, just like RAID, but it's for tape. So we not only stripe the data across the tape, but we stripe the data with parity across tapes so that we can actually don't have to mirror our data anymore. We actually RAID it across the tapes with XORs, and we're able to have reliability and availability for our data on tape. And that was able to save us, instead of mirroring the tape with $16 million, we increased our media cost by 20%, allowing to have that rate cost involved in our environment. So it's actually only, for the environment for 380 petabytes, it's still in the $17 million for media costs over the cost 5 years. The futures, the type of environments that we're looking for in the Blue Water system and our futures are data movement. So we want users not to have to store their data and take their data off the supercomputers and then store it themselves. We want to evolve that so that as users store their data, it moves in the tiers of storage. And all the different disk environments are starting to do this tier movement based on block, but it still doesn't include or scale to the levels that we're looking at for 21 petabytes. And to scale it and put it into a tape system after that. So that's one thing that we're working with, and being able to take it out of a system and put it into a secondary system while still allowing users to be able to see the namespace and be able to cover all that data and be able to request it and actually have it come back automatically from different systems. I think that's about it that I was going to talk about the Blue Water system and how we're using tape. We've 4 very large SpectraLogic libraries. We're using the JAG tapes, the TS1140 tape drives from IBM. It had the performance that we needed. The LTOs did not have the performance. The archive system goes at 100 gigabytes per second. So being able to take that terabyte a second file system off the Blue Water system and be able to cram it into an archive system going at 100 gigabytes per second was a requirement. So we're able to use the JAG drives for that. We currently have 244 tape drives spread across 4 libraries. We are adding 2 additional libraries and another 122 tape drives in the next 6 months to that environment to bring it up to 366 tape drives.
Michelle, that's amazing. It's one of the reasons we have the lines muted is so you wouldn't hear everyone gasping as you went through some of those statistics. It's really amazing what you guys are doing in the computing space, and your use of tape is obviously fascinating. It's one of the things we'll be discussing today, and I'm sure we're going to call on you in the panel discussion. But let me ask you briefly before we move to our next speaker. It sounds like tape was not your first thought when you thought about a multi-petabyte type of archive that could be accessed directly as nearline storage. What are your thoughts now that you've moved into this environment?
Disk is always easier, right? Having it in the same file system, having it in the same namespace, it's easier for the users. They don't have to move it back and forth. But I have to say that the tape environment isn't. We currently have 40 petabytes of media in the environment. We've been up and live for 6 months.
Wow.
We actually have to become better about how to manage that media so that the libraries are all 4 busy right now. That's one thing that we're trying to manage. We see hot spots and we need to make sure that we manage that media so that it's spread across all 4 libraries. But I have to say that it's working out pretty well. It's not as horrible as we thought it was, coming up with this huge tape solution. We thought we were going to be on roller skates, right, running around replacing everything and all the problems we were going to have. And it's not as bad as we thought it was, but I would have to say that we are stretching the limits of a lot of the management software that's out there today.
Well, and that's beautiful that you guys are doing stuff like that, because it helps all the rest of us, and that is certainly where this industry is headed. So we love seeing you at the forefront of it, and thank you again for sharing your insights and your experience thus far. And if you can stick with us, we'll come back to you. Thank you, Michelle.
Sure. Thank you so much.
All right, next up we have Scott Lee speaking with us from SCI-Arc. Scott, are you with us?
I am.
All right. Tell us a little bit about SCI-Arc and what you guys are doing there.
Yeah, absolutely. So we're a little smaller scale operation than the previous speaker. But
most of us are.
Absolutely. So what SCI-Arc does is we digitally preserve cultural heritage sites around the world. And we archive and disseminate that data to the public free of charge. And we accomplish this goal through laser scanning and other reality capture software. Let's go to the next slide. Here you see the Banyang Buddhas in Afghanistan, and this was kind of the impetus for the start of our company. Our founder, Ben Kassira, developed laser scanning technology, and the laser scanner, what it does is it uses a laser to create a very accurate and detailed 3D model of these sites. This technology was originally developed for the architecture, engineering, and oil industries, and after Ben sold all of his patents for this company, he started his own foundation, and after the Buddhas, let's go to the next slide, were destroyed by the Taliban in Afghanistan in 2001, he realized that the technology he developed could be used for good, and that's kind of the foundation of SCI-Arc. That's where we started. We could use this technology to document these sites that are destroyed. Or every day, pretty much, throughout the world, we're losing these heritage sites. We're losing to arson. This gate in South Korea was lost to an arsonist, and that is a project we have in our archive. We document it. We have a detailed record. They're using the data to reconstruct it. And, of course, other than terrorism and war and other human conflict, there's the climate change. There's global warming, there's rising floodwaters, there's pollution here in Giza. The deterioration of the pyramids is quite rapid due to this. So that's one of the reasons why we do what we do, to document these sites and have a record and store it for humanity.
Amazing.
This slide here is what you see is we've documented over 100 sites around the world, and that's just the start of it. We are introducing next month publicly our 500 Challenge. And the 500 Challenge is to document 500 sites in 5 years. Here's an example of Pompeii. It was one of the sites we've documented over in Italy. The next example is Mount Rushmore, which is a huge technological challenge, just how to use the technology to document something so monumental. And we developed a lot of cool technology just to do this project. And on to the 500 Challenge, 500 sites in 5 years. And with that, we're relying on partners throughout the world and service providers donating data to our archive and kind of ramping up our efforts to collect the data. With that brings the challenge of how do we store this data, how do we store it reliably and safely, and doing our own research. And we're a very small organization. We're only 12 team members here at SCI-Arc, and have a small office and pretty small budget, and we are a nonprofit. So we looked at all the storage solutions out there. We were using hard disk and upgrading our server every year, but the cost of upgrading the hard disk server was too much for our company as we were growing, and we researched a few other options, and the LTFS system proved to be the winner of our research. Our data growth is growing about 30% a year, and with the 500 new projects that we hope to have in the archive in 5 years, we expect to have 2 petabytes of data here on site. Just to let you know how much the technology, the laser scanning technology itself, is rapidly growing. The machines today were just three years ago at Mount Rushmore, we collected 3.3 billion data points. And what those data points are XYZ coordinates in space, and we store those in a text file. So that's a 3.3 billion lines of text document, essentially, and it's 200, 300 gigabytes of data per file there. So we took 2 weeks to collect 3.3 billion data points 3 years ago, and late last year we did 3 billion data points in 6 hours. So we're rapidly collecting this data, and it's growing exponentially like most industries. Let's go on to the next slide. So the need for data protection. Our office here is in Oakland, California. We're right by the Hayward Fault, so we're susceptible to the same types of natural disaster as these cultural heritage sites. So the LTFS system offers us reliability and 30-year shelf life, which is great for us. Let's move on to the next slide, please. It's great for a small business like SCIARC. We don't have the facilities to store massive data centers. We just have a small server room, and the LTFS system meets our building's power requirements due to its efficiency as well as the cooling. We didn't have to bring in a specialized cooling system for it, which really helps us out. Another advantage for us is that it is a NAS system. We were talking about this in the office for 6 months getting it in place. We helped put it in place over the weekend, and some of my team came back the following week and was like, "Oh, where's the system?" They didn't go back into the server room to check out the new machine, but what they realized from their end, they didn't realize anything changed, which is really great. So they just use it as a regular server.
That's beautiful.
So part of our system, when we collect all this data in the field, we're at these sites around the world collecting data. We throw it on an external hard drive, back it up in triplicate in the field, and once we get it to our office, we drop it directly onto the LTFS system and drop it onto our server, our hard disk system. And the hard disk system is still where we process all the data from due to the speed which we can process the data from off the server. And that data then automatically gets backed up every week and is taken off site. One of the great things is we write 2 copies all the time, and every week one of those copies goes off site. That's kind of our weekly backup system. And then we also have what we call our gold copy, and that's after the raw data, when it comes in, it goes to the gold copy, as well as the data after the project is finished, we drop it onto what we call our gold copy. And that is stored in a separate off-site facility across the country underground in a safe environment, less susceptible to the dangers and natural disasters that we have here in California. And then the next slide, please. So we've had the solution in place for just about a year, 10 days shy here now, and we have had a growth rate of 34% in that first year, a little more than our 30% growth rate that we anticipated. And next month we are, like I previously said, are launching the SCIARC 500, which will be our big event over at the Tower of London. And at this we'll have partners in technology industry as well as ministry officials and cultural ministers throughout the world. And we hope this is an impetus to get all the thousands of projects that have this laser scan data and are sitting in universities and cellars and on hard disks throughout the world. We hope this will be an impetus to get all that data over into our archive and give us the ability to get it out to the public and store it safely for future generations. Cultural heritage is very important. It's our collective memory. It's our human history, and it's something we take very seriously. And the LTFS system is a great way to store it, and that's currently the best way we can think of. So that's why we adopted the technology. And
Scott, it's an amazing story, what you guys do and how you do it. And it's interesting for all of us here today who are joined in listening to this. We hear from kind of extremes in the size of the data center or maybe the number of people dedicated, but both of you creating and capturing and having to access and work with such large amounts of information, which are doing such important things for the world. It's nice to get that perspective of how really really at the core of it, we've got a handful of certain options, and seeing how different people are deploying those and getting the best use case out of them is just fascinating. So thank you very much for presenting. And with that, we are going to move on to our panel discussion. I don't think our moderator for this really needs an introduction to most of you on the call today. Robert Amatruda is Research Director at IDC, where he covers data protection and recovery. You've probably seen him speak at trade shows, heard him on previous webinars, maybe read his words in the many articles he publishes, or at the very least you've seen him quoted in a number of articles that cover our industry. We're happy to have him moderating today's discussion. And Robert, I think we've given you a lot of good stuff to work with here. Are you with us?
I am indeed, Bob.
All right, we're going to turn it over to you.
Great. Listen, great to be here. Thank you for asking me and IDC to participate in this event. Before I start really fielding questions out to the respective panelists of the companies, I'd really like to take a minute to step back and talk a little bit about the industry. Really not in terms of performance or speeds and feeds or anything like that, but as I've followed the data protection industry for some time at IDC, I really think the tape industry is very unique in a lot of ways. I really see three key themes that have come out of the tape industry recently, and one of those themes is really new innovation. I think there is no shortage of announcements of companies that are coming out with new use cases for tape, really beyond the traditional role of backup. And we just heard from two customers that are actually utilizing tape in really what I would call future use cases, if you will, or growing use cases. And another theme that I really want to emphasize is that there's more investment that's going on in the industry from all of the respective companies that are participating in this initiative. Really active roadmaps, new product development, new iterations of products that are coming out. And also, more importantly, it really demonstrates continued commitment from all the vendors that are on the phone and participating in this event. They've really brought to market in recent years new products with greater resiliency and greater scale and improved economics. So I really believe that the tape industry still is a very vibrant and evolving group out there. It's an industry that really has been able to embrace the changes that have been driving the overall storage and compute industry. And I think the two panelists that preceded me really demonstrated that in great detail. So I would really like to start to queue it up here with some questions to the panelists here. And I know there's quite a few of you out there, so what I will do is I'll throw out a general question here, and maybe you can work together and pass the baton. I think brevity is always appreciated as we will adjourn the call at the top of the hour.
And Bob, I will say real quickly here, we've got all the members of the Tape Council listed on the screen. I know that we have online and unmuted for comments. Let's see, I'll just read them in the order they came in. Crossroads, Fuji, Overland, Quantum, IBM, Oracle, BDT, HP, and Spectralogic. So quite a few of our members here to give commentary and hopefully, briefly, as you mentioned, to pipe in today.
Absolutely. Thanks, Bob. So let me open it up to the participating vendors that you'd rattled off here. The first question I really have is really how service providers have been utilizing tape for cloud storage infrastructure. Why don't you guys talk a little bit about really those particularly the cloud and service providers in terms of new customers, new use cases, and some of the dynamics that you see in the marketplace.
All right. Do we have someone willing to jump in there?
We have someone stepping up here. I can anoint someone.
Hi, this is Childers. Sorry, I was talking to mute here. I think that the biggest thing that we've seen in cloud is that the shift from cloud is kind of a naive view of what cloud was. People kind of thought there was some special technology up somewhere in the clouds that was taking care of data storage, but the realization that cloud is really a connectivity to a data center. It's a methodology. And at the end, you still have all the same issues that you would have in a traditional data center. It is a traditional data center, just accessed differently. So we're seeing a little bit of a spectrum in a cloud sort of sense from a tape storage point of view. We see people who are using tape to protect their data as they did in a traditional data center because they have requirements to their clients to protect it, so they're doing traditional backup. So that's one use case. But we also see this emerging sort of archive use case in the cloud where they're fundamentally going after the file-based object store, sometimes using LTFS, sometimes using their own firmware. But that seems to be the most interesting and growing part of the cloud. So I'll stop there and let somebody else so I don't ramble too long.
So this is Tom. Oh, go ahead.
Oh, so this is Mark Pastor with Quantum. The other interesting use case I see, hello Robert, the other interesting use case that I've seen is where companies are using portability aspects and in many cases taking advantage of LTFS to actually seed some of the cloud storage, upload it, and then it's also used as a vehicle for distributing user content. So people are using a cloud service as a repository for customers, who can build up an inventory of content and then, serve it off either online or, in bulk via, portability using cartridges, things like that. So another service model I've actually seen that's active today.
Mm-hmm.
This is Chris Ilg from Oracle. Can you folks hear me?
Yeah, loud and clear.
Okay, great. Just one more comment that I wanted to make was I think from the service provider's perspective, when they are trying to monetize their investment in their storage infrastructure, particularly service providers that are very focused on offering storage as a service, in particular maybe archive as a service, but also including backup as a service. When they look at the investment that they have to make in their own infrastructure, tape storage really comes to the fore as far as being able to monetize it quickly and probably more efficiently than any other type of storage infrastructure, and that's all due to the basic and inherent economics of tape storage. So I think from the service provider's business perspective, if he's a storage as a service provider, particularly backup as a service or an archive as a service provider, that tape storage allows him to really monetize quickly, efficiently, and to probably a greater extent than any other storage technology.
Yeah, I would agree that. This is Bob Conway from Hewlett-Packard. I think what we see is people using the infrastructure, including tape, to get that minimum cost per gigabyte and lowest total cost of ownership. And that drives their business model to allow them to offer low prices into areas where people are getting much better functionality than they would have otherwise got from smaller systems. And I think that use model where people are using the cloud as a distribution point for content is also a very, very valid thing.
Hey guys, let me throw out real quickly. We had one of our participants write in a note here saying, and it's along the lines of what we're discussing with these use cases, says, I'm seeing a push more towards tape in archiving as disk-to-disk takes over the backup role. Does tape still have a place in backup? And if so, where? I think several of you have commented to that, but does someone want to say something specifically to that, where tape is playing in backup and how?
I could speak to that. It's Bob Conway again. I think we see very much a model of disk to tape, where you get the different elements playing well together. So you've got very fast time to data with disk to disk systems and very frequent backup schedules, whereas when you move it off to tape, you've got that longevity, you've got the resilience to natural disaster and all of the data protection and archiving opportunities for just long-term data storage at a low cost. So we believe that there's a big play for the whole ecosystem there, and it's not an either-or argument. It's really just an or thing, an and thing rather than an or function. Sorry, get mixed up there. So you would have disk to disk for the immediate backup, but then you would move it off to tape for resilience. There we are.
And this is Jeremy Surratt with Iron Mountain. So more and more of our customers have been talking to us about hybrid strategies, exactly what you were saying, where they are using different types of data protection technologies for backup. We did some analysis on our data in terms of the services that we provide to our customers, and it's one thing to hear about the customers' change in strategy. It's another thing to see it, and we definitely see a change in behavior where we have consistent growth in tape storage within our vaults, but we see a significant reduction in the amount of tapes being called back for backup and recovery rotations. So I think the numbers show that customers over time are using more and more tape. A lot of that tape is probably being used for archive, maybe snapshots of their environments, and are staying within our vaults longer. So I think backup and recovery is still being used quite a bit, but archival is really growing in popularity.
This is Tom from Oracle. Just to kind of add to that, so data protection, whenever anyone runs the survey, what do you use for your data protection strategy, at least among enterprise customers? Do you use disk or tape? You get 80% plus that say yes. So they use both. So the question is why? As previous mentioned, you may dedupe to disk, but for the data you're holding longer, you put it on tape, which is actually kind of a little closer to the archive use case, but a lot of people don't have separate archives today. They actually use their data protection strategy to be their archive. The second thing is the safety net, right? So if you do backups to disk and you dedupe and everything's working great, that's wonderful. If something happens, you could lose data before you realize you've lost it. Tape provides that safety net role. So maybe the answer to that is to not talk about data protection or backup, but maybe split data protection into pieces. You have your short-term data that has to be restored, but then you also have maybe a DR, a disaster recovery plan, where tape is an excellent fit. So we see people using both. And then to the previous question about cloud, that actually is a great friend for tape for data protection because, face it, the economics of tape don't work at 100 gigabytes. Okay, so we're not going to back up individual laptops anymore to tape drives, or not too much. But when people start, communities of people use their internet service provider for their backup target, and they back up to a cloud, now you're talking the economies of scale where tape plays very, very nicely. So there's actually room for tape to grow in data protection, given what's going on with cloud.
This is Perry Grover with Overland. I just wanted to echo all the comments, and including what Tom just said. Certainly we see in our customer base an increasing use in terms of tape for archiving in cloud and et cetera. But I would say probably the vast majority of people are still using tape as a backup device. And to the points that have been made earlier, it's while a couple of years ago the probably one of the hottest topics in the industry with tape versus disk, and it's not about that anymore. Users have become much more sophisticated and realize that it is a combination of the two for the ideal situation. And at the end of the day, it's really difficult to beat the economics of tape, particularly for long-term storage. And customers have a lot invested in tape, so it's sort of a if it ain't broke, don't fix it kind of scenario. So we still see quite a number of people using tape from straight backup.
This is David Surf with Crossroads, and I think Perry has a good point here. Is one of the things that we're seeing is as more intelligence comes in through software layers that can incorporate a blending of the technologies, whether it's going to be flash and disk and tape, that allows the customer to really meet what their objectives is. And those combine data protection through leveraging things like LTFS to where we can extend the concept of data protection beyond just backup, but it's a policy. And what's nice about LTFS is that in the customer's concept, he may be thinking of a file, and he wants to be able to think of that as an available online thing that has a particular type of performance. They can look at combinations of technologies and policies at a file level that can then enable data protection to where it can be copies into the cloud, copies in tape, different things. So I think we'll see more and more software intelligence that really blends these things together and lets customers take advantage of the best things, best of all technologies. And of course, tape is going to bring lots of value from the inherent natures of its portability, economics, reliability into that equation.
Excellent. Is any other comments on tape and disk being integrated and used together? We certainly see the blending of the technologies and the different use cases that disk and tape really bring to a customer environment, and it's really driven by application. Recovery point and recovery time objectives really drive some of those decisions, whether customers really, when and how they use disk and tape together. So to all of your comments, it really is not in a one or the other, but really about how one utilizes and manages those technologies.
Well, and it also comes down to, this is Michelle Butler, this also comes down to the risk that you're willing to live with, right? So what are you willing to live with, and what you can't afford to lose and what you can restore on your own without having to use that backup or having to go to it, or et cetera. So, how you plan out your technologies that you use, whether you just use JBODs or you're going to RAID them because you don't want to lose a disk. You can't lose that data as it's scratched, and it really doesn't matter. If you really lose it, everybody can recompute. And how fast it takes you to restore that depending on where you've actually stored it. So there's a lot of level things here. We're in real use here at NCSA, we use both. So we use snapshots within the file system, but if you lose that file system, you lose all your backups, and it depends on what customers we have there of what we back up of theirs. We can back it up to disk on another disk platform, which is fast, but then we only keep that for 30 days. So if they found that they've deleted something or someone's actually gotten into the environment, some kind of corruption, or even a hacker of some sort, they can only go back 30 days. And then if we've got some real serious data, Land of Lincoln Library, something like that, some data that we just can't lose, even if we did get a hacker, we will put that on tape. So I agree with the blending of technologies, but it depends on what are you really willing to live with. Can you live with something taking 2 or 3 days to get back, or do you need it back within an hour, or you don't need it back ever? Really, you need to make that evaluation as you're trying to choose which technology you put your data on for backup.
So Michelle, really well put. It really is about risk, time, and cost.
Correct.
In terms
total
of
cost of ownership, right?
Exactly. So very, very well put. So really, to keep the agenda moving here, I would really like to move on and throw out another question to the panel. really about the growing ecosystem, particularly for LTFS. And SciArc provided really a great overview of really new use cases for tape and new solutions, and being able to, as Michelle from NCSA intimated, really, tape has had this legacy of being cumbersome to really deploy and manage. And innovations like LTFS has really freed, as I see it, the user community up from proprietary interfaces and formats and application software stacks to really make the use case for tape much broader and much easier to use. So really the question I want to pose to the panel is each of you can comment about really new target markets and new customers for LTFS, really being able to present tape as a NAS device. So really stripping away that proprietary nature of the technology. So let me open it up again to the panelists. So please jump in.
Yeah, if I could take that, I'd go at that. There are a number of software and appliance solutions available today that do provide a NAS-like connection to tape libraries. I think the objective here is to enable a simple, low-cost, and reliable method of writing and retrieving archived data. So tape as a NAS solution effectively virtualize the tape libraries, and then they present the active archive as a network share using industry standard CIFS and NFS protocols. That then allows the users and the applications to store, search, access, and retrieve the data on low-cost tape-based storage without administrator intervention. So that's a big plus for people, and they don't need to manage the individual pieces of tape media. So in these circumstances, I think that the data is presented in the form of a standard subdirectory that people are very familiar with. It's just an Explorer page, and they can click on the files they want and get them. And this continuous visibility and accessibility is why tape as NAS can be superior to using traditional backup tools for archiving the data. So for example, the HP StoreEver tape libraries are all qualified with both hardware and appliance, such as Crossroads Strongbox and Cache, and with software solutions, including QStar, Archive Manager, Zendata Archive Series, and FileText Storehouse, and others. And these solutions are really providing a NAS gateway to tape, and they provide all people the option to store data on tape in the LTFS format. Some also provide their own proprietary methods, of course, which we don't want to bar, but that LTFS option makes them more open and easier to access wherever you are. And there are a lot of different solutions being used here for file storage, email, SharePoint, database archiving, healthcare imaging, tax, DICOM, broadcast, and video. So there's a lot of work going on there. And a number of people are using this functionality in order to share their files, as we've already said, via the cloud and via moving tapes around, and even by using just simple messaging through the internet. So I think there's a fantastic opportunity out there for people to get a lot of benefit.
That's very true. This is Dan Greenberg from Fujifilm. We use LTFS as really a foundational feature of our PermaVault service in many different manners. For end users for users to send us their data, for portability aspects of it, as well as from a service provider perspective, one of the complaints or fears of customers would be, if they were to move files into the cloud or off-site, that they would somehow lose control of the files that they've stored at a service provider. But having everything on LTFS as the basic building block allows us, in the case of a customer wanting to move from different service providers, allows us or gives them the freedom to actually recall all of their files in bulk. So it's very, the non-proprietary nature of LTFS is, I think, a very powerful feature for both, on-site as well as off-site solutions. There's a few different end users and industries we see that are pioneering tape and its use in archiving in particular. From our vantage point, there's industries like media and entertainment and medical that are creating massive amounts of unstructured content. And this data, their content, is their business, and so of course, they're never going to delete this stuff. And as mentioned before, at the same time, we're seeing users also moving away from backup, from backing up this content and tossing it into the vault, because they really see the value in maintaining a visible connection to all of their content. And as said before, because of this content is in fact their business, and with it now they can provide new products and services to new customers, there's the flip side, and that's the cost-benefit analysis. But really, the way that we at Permavolt have been successfully able to merge disk and tape to provide multi-user, multi-tenant accessibility to files, this is really where we feel that our industry is in the driver's seat because of our advantages in cost, power savings, and longevity. And now, we have a level playing field where we have the ease of access and the same sort of accessibility that other solutions have. So we really find or see that we can satisfy these customer use cases around storing a second copy in the cloud, or transferring information, sharing it in the cloud, and we can deliver it to them at the required price. Because it is this cost-benefit analysis. While we talk about the archive market, the assumption is that customers are going to take this content that they have essentially offline and now spend money on putting it on an online-like system. And really, tape is the only thing, or the only architecture that can provide that the required cost per gigabyte in TCO that can make that happen.
This is
So it really is game-changing technology here. It's the ability to take otherwise static data that's been vaulted and be able to build a new annuity model or a new business model, or monetize that data really in a different way from what I see or have seen in the past, with tape technology really being used as backup technology.
Yeah, Bob, this is Tom from Oracle. Just to add to that, so if you archive correctly, earlier I alluded to people using their data protection system and architecture to really create an archive. If you archive correctly, two really good things happen. One is exactly what you just said. That data now is something you can do something with because you can find it. It's a file system. You can access it. You can do analytics on it. The other thing is what it does for your backup, which is it greatly reduces the amount of data you have to back up, because if your archive data isn't separated out, if it's all mixed together and you're backing it up all the time, you're spending too much money on your backup system. If you put it in an archive, a good archive system, yes, it has the CIFS, NFS front end. It has the HSM, if you will, tiered disk and tape and policies to move it and make that all easy and all that. But it also handles the data protection piece for you so that you're not backing up data that's not changing every single night or every week. So there's a lot of benefits to archiving correctly, and tape is an excellent fit for archive.
Excellent. Can anybody comment on the expanding ecosystem of really new, particularly new vendors and new application providers that things like LTFS has provided. I mean, I've had the opportunity to talk to some of them, and I'm really struck by the new group of solution providers that really the tape vendors never ever had an ability to link up with, let alone work with and offer a solution set built around. Can any of you talk about that?
Well, I think without mentioning specific names, I think if you look at different areas of work, for example, media and entertainment, the media and entertainment industry, which has moved more and more to rendering special effects by computer. There's a fantastic amount of work going on there with the opportunity for LTFS files to be passed around. In healthcare, obviously lots of imaging. Video surveillance is a very interesting one. I was thinking about this earlier when we were talking about the disc-to-disc and tape situation. Video surveillance is going through a bit of a change in a lot of geographies, because in the past, just because of the limitations of systems, a lot of places have only held video surveillance data for 90 days. But there are more and more laws and regulations coming in where authorities and governments want people to keep that surveillance information for years, 3 years, something like that, so that they can go back to incidents and forensically study all of the tapes. And if you think of a major airport, somewhere like Los Angeles or San Francisco, the number of cameras they must have there and the amount of data being generated, you have to manipulate it at first through a disk system. But in order to store it for 3 years or more, you're going to have to put it down to something like tape. So there are really all sorts of solutions where increasing volumes of data are going to be wanted to be kept in a way that it hasn't happened in the past. And I think the ideal solution is a sort of disk-to-tape environment. I hope that helps.
Robert, I would add one more thing, Mark Pastor again. To your point, what I see happening a lot now is many of the representatives, companies represented on this call, have LTFS solutions, whether they be appliances or software solutions. But what I'm starting to see a lot more of now is file management and asset management companies, application software themselves, now starting to integrate LTFS. So in many cases you don't even need an appliance to be able to get storage to LTFS. So I see very much aligned with the comment you made that there's a lot more providers who are actually leveraging LTFS technology.
It truly is an industry that's undergone a remarkable evolution. Really, new investment and new products and expanding use cases. I don't think you can actually point to as many technology industries that have been around for more than 50 years that have actually done that. So, I look forward to another year where we'll see much more innovation being brought to market by all of the vendors on this call. And I know we're approaching the top of the hour, but it would be very interesting to kind of gauge the barometer, if you will, for the next year. Maybe each of you can talk specifically about some of the trends you see on the horizon, the opportunities that you think you'll enjoy, and continue to cooperate while build your own businesses and solutions.
Yeah, hi. This is Ed Childers again. I think the interesting outlook in the next few years is somebody earlier said it. It's not going to be about do you use disk or flash or tape. It's going to be about how do you use them all together in the right proportions for the specific use case. I think we're moving past the battle of do you use disk versus tape. I think it's more how do you use all of them. And disk is really going to be changing with the introduction of SMR, the shingled, where they're going to have to move into the storage stack management of that shingled disk. That's very symbiotic with management of tape. So I think we'll see a greater focus on integrated solutions combining all the technologies and blurring the lines. We'll say technology agnostic storage and allowing customers to move data to the right tier without having these islands of data. So that's my 10 cents worth.
Yeah, Ed, I really appreciate that insight. Anybody else?
I guess the only thing I'd add, Robert, is what I see and read about is that the data capture tools are continuing to accelerate in terms of what forms of data capture is available, for a broad set of applications. We learned like at SciArc today. So data capture is on the rise, and therefore there's going to be a lot more, reference data. And I think things like analytics tools and that sort of thing are also, a huge trend. And so I think that's going to continue to drive, what I think is commonly projected as a substantial growth of archive or reference sort of data, which I think really helps support and boost many of the use cases that we talked about today.
So really exciting times.
And if I could comment as well, I think one of the things we're going to see more and more of is the active archive. A lot of people think of an archive as being the tape we send off to a store somewhere years ago. But what we're really seeing is the ability to archive and access data and reuse it and re-monetize it in different ways that were never thought of when the data was first recorded. And I think these are going to be big opportunities for us as we go forward into the future.
All right. And it looks like we're at the top of the hour, so we're going to bring this to a close. I would like to extend a very big thank you to Ms. Michelle Butler from NCSA and Mr. Scott Lee from SciArc for taking time out of your obviously very busy schedules to contribute and tell us about your use cases. I want to say a big thank you to Mr. Amatruda for doing an outstanding job of moderating and guiding us through a panel discussion. And, of course, thank you to all of the TAPE Council members. When we kicked off, I failed to mention, I believe Iron Mountain was with us. We heard their voice, as well as Tamberg Data. Thank you all, and thank you all to the people who've attended and shown interest in this message. As I think you've heard today, we do have very exciting time for TAPE ahead. We look forward to it. There were several questions in reference to availability to this webinar. We do have a recording that's been created, and that will be posted at the tapestorage.org website that you see at the bottom of your screen now on the panelist page. So thank you again to everyone. We will look forward to chatting with you again next year, and we'll keep you informed of what's going on. Take care, everybody.